Now we are in Google Classroom, here Classbox section. Topic 5 chi-square test. Material. Handout. So we have studied 3 tests. Today the last application, number 4. Chi-square test of independence. The format of writing HO is the two variables are independent. You have to write the name of one variable x and another variable y. X and y are not related or independent, like this. X has no effect upon y, but the best is x and y are independent. X and y are not independent. This is the format of HO and HA. The statistic formula is formula 8. Formula 8 and 9 are the same. How to find E? EIJ is equal to RICJ divided by N. EIJ, I is row number, J is column number. There are two variables. One is called row variable, another is called column variable. Both are nominal level measurement. Therefore, you have to deal with frequencies, percentages, proportions, relative frequencies. One variable called row variable has small r values, r rows. Another variable called column variable has c values, c columns. In reading critical value, you have to use chi-square table, the same table. The degrees of freedom is r minus 1 times c minus 1. R is number of rows, C is number of columns. You multiply number of rows minus 1 and number of columns minus 1. You will be given two-way frequency table. You call this table contingency table or cross tabulation of variables x and y. Here I write some remarks. Test statistic and critical value are never negative. All 4 tests are right-tailed. That means the further test statistic to the right is the statistic most and most significant. That means the rejection region is on the right of the critical value. Test statistic measures the total difference between observed frequency and expected frequencies. Total squared difference, we can say squared. Therefore, never negative, always positive. An example is on page number I give one example, problem 14, page 8. A survey was conducted by an auto repairman to determine whether various auto ills depended on the make of the auto. In problem 14, the contingency table is given. The two variables are make here in the table. Make variable has 3 values, A, B, C. Make A, make B, make C of the auto. Another variable is type of repair. Type of repair has three values. They are represented by three columns: electrical, fuel supply, and other. So for each auto, he recorded two variables: what make, what problem. Make A or B or C, what problem, electrical, fuel supply, or others. Row total 60. Let's study terminology first. Make variable, type of repair variable, row variable, make, column variable, type of repair. Values of make are A, B, C. Nominal level measurement, type of repair variable has three values: electrical, fuel supply, and others. So we write small r is equal to 3. There are 3 rows. Small c is equal to 3. Number of columns is 3. And in each box, row A electrical column, you see two numbers 10 and 16.5. 16.5 is small. 10 is written big. 10 is the observed frequency coming from the sample. After observation, he saw 10 autos which are make A and which had electrical problem, like this. And in his record, he saw 20 autos which are make A and which have fuel supply problem, like this. So first row, therefore we say O, observed frequency, row 1, column 1 is equal to 10. We write O11. The first one is row number, the second one is column number. Row number 1, column number 1, observed frequency 10. Row 1, column 2, observed frequency 20. O12 is 20. O13 is 30. O11 plus O12 plus O13 is equal to 60. 60 is denoted by capital R sub 1, R1. Row 1 total frequency. Row 2, row B. O21. Row 2, column 1, observed frequency O21 is equal to 15. Row 2, column 2, observed frequency O22 is 25. O23 is 35. O21 plus O22 plus O23 is equal to 75. This is R2, row 2 total frequency. Similarly, the last row, row 3, O31 is 30, O32 is 25, O33 is 10, O31 plus O32 plus O33 is equal to R3, row 3 total frequency 65. R1 plus R2 plus R3 is equal to 200. He observed totally 200 autos. Therefore, we write small n is equal to 200, sample size, total frequency. If you add up column 1 frequencies, 10 plus 15 plus 30 is equal to 55. This is denoted by capital C sub 11. Column 1 to row 1, column 1, total frequency. C2, column 2, total frequency 70. C3, column 3, total frequency 75. C1 plus C2 plus C3 is equal to N 200, and so on. Because the data are frequencies, nominal measurement, we have to deal with frequencies, proportions, percentages. We should recall the meaning of percentages. Therefore, I started with percentage questions. What percent of cars in the sample? What percent of cars in the sample? You consider the whole sample 200. Out of 200, what percent needed repair for electrical? What percent are electrical? So electrical 55 from 200. 55 from 200 is what percent? So you divide 55 by 200 and multiply by 100. 27.5%. That means in the outdoors in his job, there are 200 outdoors. Out of them, 27.5% have electrical problem. Okay, what percent of make-be outdoors needed repair for electrical? Second question. You consider only make-be outdoors, therefore 75 below. Out of 75, how many are electrical? 15. You consider only second row, total 75, second row, column 1, 15. 15 out of 75, 20%. So what is the use of studying percentages? By comparing percentages, you can draw conclusion. For instance, according to those data, can you say that make-be outdoors are better than A and C in electrical? I answer no. Why? Explain. In make-be outdoors in the sample, 10 from 60 have electrical problem. That is 16, about 70% in A group. In B group, 20% have electrical problem. In C group, 46% has electrical problem. So we can guess that in ABC, A is the best in electrical problems compared to B and C. Only the smallest percentage have electrical problem. B is in the middle and C is the worst. In C group, if there is a problem, nearly 47%, yeah? A little more than 46% of the problems are electrical problems. So we can guess that in C group, C outdoors are mostly weak in electrical parts. Okay. Comparing percentages, we can draw conclusions like this. The next question, what percent of outdoors needed repair for electrical? So 55 outdoors in the sample needed repair for electrical. Out of them, how many are make-be? So 15. Yeah, 15. So 15 from 55 is 27.27%. And the last one, what percent of the outdoors in the sample? The whole sample, 200. What do you count? Which needed repair for electrical and are make-be? Both. So in electrical column, make-be row, you see 15. 15 out of 200 is 7.5%. Okay, after that, you can ask, do these data present sufficient evidence to indicate a relationship between outdoor make and type of repair? Yeah, the two variables are dependent or independent. This is the meaning. There is a relationship between the two variables of 5.05. So after that, you can understand all these questions and answers. There are two variables, make and type of repair. Level of measurement, both are nominal. What are the values? ABC for make and electrical fuel supply and others for type of repair. So test question. What does this mean when we say that the two variables are dependent or the two variables are independent? Then we have to compare proportions of three problems, in three mix. if we see different proportions of different problems in different mix, that means make ABC are different in problems. So problem depends upon make. Some make have little problems, some makes have bigger problems, like this. So we have to compare only proportions. Generally, different proportions indicate the relationship. The same proportions indicate no relationship. So statistically, we have to compare proportions. So in such a case, the test we have to employ is chi-square test of independence. Chi-square test of independence of two nominal variables. And after that, the next question is value of O12. I asked this for remembering notation. O is observed frequency, 1 is row 1, 2 is column 2. You can see 20 in the table. E32, row 3, column 2, expected frequency. So, expected frequencies come from HO and the assumption that the sample will follow population. That means if HO is true for the sample, if HO is true for the sample, what frequency should we have in row 3, column 2? The formula given is R3C2 divided by N. Row 3 total frequency 65 multiplied by column 2 total frequency 70 divided by 200. So 22.75. 22.75. This is E32. We have to find E11, E12, E12, E13, and so on. E21, E22, E23, E31, E32, E33. We have to find all 9 expected frequencies in order to compute the test statistic. Okay, now you can see HO, the two variables are independent. You have to write down the names of the variables. H is not independent or dependent, you can write. Critical value reading, only chi-square, alpha 0.05 or 0.01, and you have to know the degrees of freedom. Number of rows are small r is 3, 3 minus 1, 2. Number of columns small c is 3, 3 minus 1 is 2. So 2 times 2 multiply 4, degrees of freedom 4. You go to chi-square table, check alpha 0.05 column and row 4. The shaded black area is on the right, in the chart. Therefore, this is right here. If the test statistic is more than critical value, we have to reject. You see 9.488 is the critical value. Okay, above you saw how to find expected frequencies for each box. So after finding each, you just employ formula 8. Formulas 8 and 9 are the same. Formula 9 is for one variable, formula 8 is for two variables. Therefore, if you add up O squared by E for the boxes in each column, then you get the first sigmas. If you add up all these sigmas, you get sigma of sigmas. Essentially, formulas 8 and 9 are the same. What we have to do is for each box of the table, you have to compute O squared by E. Then add all. After that, subtract N from them. That's all. So now you get the test statistic. Now you know how to decide. If you decide to reject HO, you write HA. The two variables are dependent. If you cannot reject, not dependent, but or independent, you can write. Here, test statistic 25, a lot more than critical value, 9.488. Therefore, you reject HO and write like this. make and type of repair are dependent. This is HA. Okay, in this problem, we didn't look for pi. Yeah? We directly compute E from row and column totals. But if you want to see pi, you can compute because pi is frequency divided by n. What frequency? Expected frequency, because pi is population frequency, population a proportion we guess from HO. So if HO is true, yeah, what is pi? Now pi is therefore HO is true, the expected frequency you have to use. Frequency, expected frequency E by n is pi. Yeah? That's all about chi-square test of independence. That's complete.